This is AS Stats. We're in Unit 5, the binomial distribution, and this is 5.3. We're just starting to define the binomial distribution and how we can use it. The last video we saw rolling the dice 3 times and how it ends up looking like a binomial expansion. So the binomial distribution is used in model situations where there are a number of different trials, each with 2 possible outcomes. Hence the word bi, as in bicycle, means 2 wheels, so 2 possible outcomes. That's where the binomial bit comes from. The general formula for finding the terms of a binomial expansion of p plus q to the power of n, where p is success and q is failure and n is the number of times the experiment is repeated, is as follows. So we would have p plus q to the power of n, and remember start then with p to the power of 0, so it's nc0. Remember probably a couple of videos ago we did one with 4, so we 4c0 to start with, but the general one is n, and that would be p to the 0 q to the power of n plus nc1. The powers of p increase, p to the power 1, power of q decreases, q to the power of n minus 1 plus nc2, p to the power of 2, q to the power of n minus 2 plus all the way to the other end whenever we have n c n, p to the power of n, q to the power of 0. So that's us for the binomial expansion. There are a few conditions that need to happen for us to be able to use the binomial. There must be a fixed number of trials. That's obviously our value n. Trials must be independent. Trials must have only 2 outcomes. We normally denote those as success and failure. And finally, the probability of success P must be constant for each trial. If these conditions are met, then we can say that the random variable x follows the binomial distribution with n and p, where n and p are parameters or the key values of the binomial.